for this question, we will have a fence that has an area of 6 million square feet in a rectangle field, and then divide it in half with the fence parallel to one of the sides of the rectangles. So we can make a quick drawing of this. We can have our length represented by x, and we can have our width represented by y. We know that our area is length times width, so x times y will be representing our area, which we know is 6 million square feet. Now, we also have to take into account that we have another x side, which is present on the other side, which is down the middle, since the farmer wants to divide it in half with a fence parallel to one of the sides of the rectangle. So the main goal is to minimize the cost of this fenced in area, and the way we're going to be doing that is by basing it off of our perimeter. So we know that our perimeter is equal to all the sides added together. And so we see that we have 3 x sides and 2 y sides. So we can write this out as p equals 3x plus 2y as our base equation for this. And so we can rewrite this original area equation as x equals 6 million divided by y. And so what we can do from here is we can try to find our y value. So we can rewrite this as 3 times x. Well, instead of x, we'll be using the representation of it, which is 6 million over y plus 2y. And so we can multiply that numerator by 3, giving us 18 million over y with, or we can rewrite it as y to negative 1 plus 2y. Either one is acceptable. And next we'll be finding the derivative of our perimeter, which is going to be negative 18 million y to the power of negative 2 plus 2. And so we can rewrite this as negative 18 million over y squared plus 2. And then we can further rewrite this as negative 18 million 2y squared over y squared. Once we get to this point, what we want to do from here is we want to set this equal to 0 to find our y. So we have our perimeter prime equal to negative 18 million plus 2y squared over y squared equal to 0, which we know will not exist here, because our perimeter prime equaling 0 when negative 18 million plus 2y squared equals 0, and 2y squared equaling 18 million, and dividing that by 2 will give us y squared equals 9 million. And when we find the square root of 9 million, we have y equals 3,000. Well, plus or minus 3,000, but we know that an area in this case cannot be negative, so we can disregard that negative and keep that as a positive 3,000 for what our y value is. So we know our y equals 3,000 feet. And so, as I note, perimeter prime does not exist whenever our y squared equals 0, or y equals plus or minus 0. So you can just X that out. So we have found our y value, and we can go ahead and rewrite this original equation with our y value input in there. So we have x equals 6 million divided by 3,000, and then we'll have our x equal to 2,000. So we have found both our x and y values, which are represented by 2,000 feet for x and 3,000 feet for y. And so the dimensions with the minimal cost for this fence will be 2,000 feet by 3,000 feet for this fence.